Sure. So my name's Con Dimitrakakis, and I'm a second-year PhD candidate here at Monash University, and my supervisors are Dr. Bradley Ladwig from the Chemistry Department here, and also Dr. Matthew Hill from CSIRO. And my research is about taking these new materials called metal organic frameworks and trying to adapt those into flexible membranes that can be used for gas separation.
So is that an easy thing to do, to put MOFs into membranes?
It's not particularly easy to do since the metal organic frameworks, or MOFs as we call them, are crystalline structures, and so it's not very easy to put a crystalline structure into a flexible membrane without having cracks and leaks through the membrane as such. So I'm researching various ways in which we can combine polymers with these metal organic frameworks into a structurally sound membrane.
Okay, so can you tell us a bit more detail about that? How are you going to make a membrane by combining polymers and MOFs that is robust?
Yeah, sure. So right now in the literature there's these things called mixed matrix membranes, which basically take the crystals and embed them into a polymer matrix. But you can still have leaks around those crystals, and ideally, since the crystals themselves are what do the gas separation, you want all the gas to go through them rather than around them. So the way that I'm approaching it is to take a porous substrate of Teflon, is what I'm using, to put a crystalline layer on top of that, and then to coat that with another polymer as well. So you have two layers of polymers with a crystalline MOF layer sandwiched in between. So then the polymer adds structural integrity and support, while the crystals do the actual separation and all the gas passes through those rather than around them.
Excellent. Okay, so can you tell us more about the particular MOFs that you're working with and why they're special?
Yeah, the metal organic frameworks that I'm working with are a specific subclass called zeolitic imidazolate frameworks, and they're very similar in structure to zeolites, but with very small pores on the order of 1 nanometer and smaller, so that they can exhibit molecular sieving. In other words, they select gases to pass through them based on the size of the molecules themselves. So since carbon dioxide, for example, is a smaller molecule than nitrogen, it can some of these materials can selectively allow that to pass through and to reject the nitrogen, and that's the feature that we're using in order to achieve this gas separation.
Cool. Okay, so you said that you're trying to make gas separation membranes.
Yeah.
What's the real world significance? Why are these important, these gas separation membranes?
Yeah. Well, in industry there's a lot of gas separation processes being used. In particular, one big one is air fractionation, so the separation of oxygen from nitrogen. So that's one big application, and there are some zeolitic imidazolate frameworks that are tailored towards those. The ones that I'm looking at in particular are for the separation of carbon dioxide from nitrogen for carbon dioxide capture from coal power plant flue gases. So that'll go a long way towards solving the issues with carbon capture and making that a viable process for the future.
So why is carbon capture important? Why do we need to be able to capture the gases from flue gas?
Well, it's been suggested that carbon dioxide in the atmosphere and the rising levels of carbon dioxide in the atmosphere are contributing to global warming and other such climate change effects. So if we're able to reduce our output of carbon dioxide to the atmosphere, as per the Kyoto protocols and all the other efforts towards this that are being done by governments around the world, then it'd be a really good outcome for the future. Yeah.
Can you tell us about some of the travel and the things that you've done outside the lab as a part of your PhD?
Yeah, sure. The perks of doing a PhD are really good, actually. I've been on 2 international trips thus far. Last year I went to India for a week to Mumbai to go to the nuclear facility there and to learn all about the facility and how to use neutrons in science for probing the characteristics of materials. And just recently I went to Amsterdam for a conference trip to present my research there to lots of eminent researchers from around the world. And then shortly afterwards I went to Italy for 2 weeks as well to go to use a synchrotron big facility up in Trieste in the northeast of Italy and to do some experiments there. And I got some really positive outcomes from that as well. So the PhD has definitely helped me to go explore the world and even to explore Australia as well in presenting my research around. So it's been quite nice.
Cool.